just gonna go ahead and wait until time before we get things started here. So just wait until everyone else joins in. Let's give everyone else just a little bit longer to show up, maybe like a minute or two, but we'll get started soon. Okay, let's go ahead and get things started. So last time, and a couple times ago, we looked at the sprint round from the 2017 Mathcounts chapter round, and we've also done the target round already as well. So today we're just wrapping up the team round. I don't really want to start up a new, a new test. I don't think, especially between this semester and the new one starting up, I think it'll be a good idea for us to just go ahead and start up a new test with the new semester, in case anyone joins in the middle, right? So I think that's what we're gonna do. We're gonna just go ahead and wrap up this test and then call it a day. If we're a little bit short on wrapping up, I'll just talk through the last few questions, and then that should work out for us. So today we might end a little bit early. We might not, but if we do, it's because it's the last class in the semester, just wrapping up the last exam, and then I think that's fine. So with that being said, let's go ahead and get things started here. So we have a couple final questions from the team round in the 2017 chapter exam, which is what we're going to be looking at here. We have 6 questions in total. All right. So first things first, did anyone get an answer to any of them? Did anyone manage to find any of the solutions at all? If you did, then I'd like you to kind of explain on that problem. If not, then don't worry about it. I might call on someone to like help me out though. So just making clear, everyone wasn't able to answer anything?
I answered some, but I currently don't have my notebook at hand, so.
Okay. All right. Well, if you remember how you did it, let me know, and then I'll let you share out a little bit.
Okay.
All right. Let's start with problem number 5. Points A, -7, 4, and B, 13, -11, are 2 points in the coordinate plane. Point P is on the segment, and it divides it so that AP to BP to PB is 2 to 3. What is the product of the coordinates of P? All right. Did anyone get to do this one? No? All right. Let's have someone help me out here. We have 6 people, right? Let's just go down in line. Okay, Gracie. Let's have you help me out here. So
yeah.
If we know that AP to PB is 2 to 3, what is the how far down is A is P, like when we're going from A to B? So let's say, for example, had A been here and B been just straight right, where along this segment would P be?
It would be slightly more to the left.
Slightly more to the left. So if this was 0 and this was 1, where would it be?
It would be at 0.4.
Yeah, it would be at 2/5, right? And the reason why it's at 2/5 is because this over here is 2, this over here is 3. We add them together, it's 5 total. So that's why we're 2 out of 5, right? So that's what we're looking at here. So we're 2/5 of the way towards B. However, we're not starting from 0. We're not going to 1. In fact, it's not like that at all. However, we can make this actually a little bit easier, because what we can do is we can think of it as, well, first off, what's the difference between their x coordinates? Difference in the x coordinates is a positive 20. And the difference in the y coordinates is a negative 15. So it might look like, oh, you have to find, the distance formula here and then find 2/5 of that distance. No, you don't have to do that at all. Because in order to find 2/5 of this distance, all you have to do is take 2/5 of this number and 2/5 of this number instead. So Gracie, what is 2/5 of 20?
It would be 4.
2/5? 1/5 would be 4, yes, but not 2/5.
Oh, 8.
Yeah, 2/5 would be 8. So if you move to the right 8, what point are you at now? What x coordinate are you at?
-1.
Positive 1.
Oh.
Right? Because -7 plus 8 is positive 1. And then, okay, 2/5 of -15, what is that?
It would be 10, -10.
That would be 3/5. No, that would be 2/3. Sorry, you're looking at 2/5 here, not 2/3.
4.
Isn't it 6? -6.
Oh.
Dividing by 5 gets you 3. Multiplying by 2 gets you -6, right?
Yeah.
Okay. So going from 4 and moving down -6, what point are you at now?
-2.
So multiplying these 2 points gets you -2. So all you had to do here was figure out what your x change was, figure out what your y change was, and 2/5 of the way down is just 2/5 of each of your individual changes. You don't need to think of it as the total change together. You don't need to do that at all. You can think of it as each individual change. Because if your total change is this, 2/5 of it would be 2/5 of the x and then 2/5 of the y. That's really just it. We just separated out the distance into the 2 components and then use the 2 components separately. Now, had you wanted to find the whole thing, what you could have done is you could have said, okay, this is actually a 3, 4, 5 triangle, because this is actually just a 3, 4. All you're missing is 5, so your length would have been 25. You could have done it that way. But I promise you, this way is a lot harder. Just think about them in different components. Now, does it make sense that 2/5 of the distance is just 2/5 of each component here? Does it make sense? We split it up into a horizontal and vertical component and did it separately. Does that all make sense here?
Yes.
All right. Any questions from anyone here? Not just Gracie. Any questions from anyone here? I noticed that the colors actually make up a pretty nice rainbow in the participant list. Seems to be just a coincidence. This is the first time I've seen that. All right, problem number 6. All right, so problem number 5, answer was -2. Your point was 1, -2. All right, problem number 6. What is the greatest number that evenly divides the sum of any 6 consecutive whole numbers? All right, Allison, let's have you help me out here.
6 consecutive whole numbers. Repeat one after the other.
Right. So the easiest way to do this is think about what your first whole number has to be. Well, you don't know what it has to be, right? It can be literally any number. Do you agree with me here?
Mhm.
So what do you want to set this number to be then?
First, do you want to try 1?
Well, we could, but if we did that, we would have to test out a bunch of different numbers, and we have to add a bunch of different numbers together. It's kind of a pain, right? Would you agree with me here?
Mhm.
Okay. So how about let's not. Well, how do we make this work for any situation then?
N plus 1, n plus 2, n plus
Yeah.
3, n plus 4.
Yeah, that's exactly it. That is 100% exactly what we want to do. So if we have n plus 1, n plus 2, n plus 3, n plus 4, and n plus 5, these are 6 consecutive integers, right? 6 consecutive whole numbers. Do you agree with me here?
Mhm.
Okay, let's add them all up. What do you get? Well, you have 6 different n's. So you get 6n, and then 1 plus 2, that's 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. Your total sum is 6n plus 15, right?
Mhm.
Now remember, n can be any number whatsoever. But what must this number be divisible by?
15.
Not quite. Because if n is equal to 1, you get 21, right? That's not divisible by 15.
Mhm.
So what we're saying here is, in order for this to be divisible by some number, both the 6n part and the 15 part must be divisible by that number that we're talking about. 6 is only divisible by 3 different numbers, 1, 2, 3, and I suppose 6. And 15 is only divisible by 4, 1, 3, 5, 15. So the biggest number that's shared there is
3.
Yeah. So this is always divisible by 3. Look good?
Mhm.
Any questions here from anyone?
Where did the 15 come from?
The n plus 1, n plus 2, n plus 3, 4, 5. All those added together. The 1, 2, 3, 4, 5 combined together to get you 15.
Oh,
Anything else from anyone? Yeah, this question's really quick, as long as you look at it the right way. Now, Allison, if you had done the method where you said, all right, let's just go and find, what happens if you take the first 6 numbers? Oh, that's 21. What happens if you take 2 through 7? Oh, that's 27. You would have found that the common factor there would have been 3, but it would have been hard to know that it always is divisible by 3. This method that we use right here proves that it 100% has to be divisible by 3. Now, if you're wondering where this idea comes from the pre-algebra book, the pre-algebra art problem solving book. I want to say chapter 3.2. So if you guys are wondering where to find more information on that, that's just in the divisibility section, 3.2 and 3.1. All right, problem number 7. All of the possible sequences of 4 consecutive positive integers less than 200 are created. One of these sequences is called orderly if the smallest member is divisible by 2. The next smallest member is divisible by 3. The next smallest is divisible by 4. And the largest is divisible by 5. What is the probability that a randomly selected sequence is orderly? Express your answer as a common fraction. All right. Anna, this one's up to you.
So
Any thoughts on this going into it?
I think there are like 196 total like possible sequences.
Okay, and what makes you say that? Can you kind of explain that a
Because-
little bit?
Because the smallest integer you could start with is 1, and then the largest integer you could start with is 196.
Why 196?
Because they have to be less than 200.
Right, so then your largest sequence would be 196, 197, 198, 199, right? 4 different numbers there. So
Yeah.
what you're saying here is we need to have this be the case, right? This needs to be the biggest, this needs to be the sequences that we're looking at. So it's easiest to just look at the smallest number. Well, the numbers between 1 and 196, the easiest way to do that is 196 minus 1 plus 1. The reason why you have to plus 1 at the end is because if you ever are looking at the number of numbers from between 2 different points, you have to add 1 at the very end. Think about, say, for example, 3 and 4. How many numbers are there? Obviously 2, but if you take the difference, it's only 1. That's why subtraction actually only counts, subtraction leaves off one of the edges. That's the easiest way to think about it. All right, so we have 196 total numbers. Now let's figure out how many sequences work out for us. So what we need is we need an n that is divisible by 2, an n plus 1 that is divisible by 3, an n plus 2 divisible by 4, and an n plus 3 divisible by 5. Well, how can we do that?
So we know n has to be even.
Right? N
So,
must be even.
So I guess,
But it cannot be 2 even, right? Do you know
yeah,
what I'm saying? Like if it's a multiple of 4, then if you add 2, it's no longer a multiple of 4.
yeah.
So what do we need to do then?
I don't know. So n divided by, no, n is equal to, I don't know.
All right. So what we can do here is we can think of a couple different things. First off, n itself must be divisible by 2. So n must be multiple of 2. N plus 1 is a multiple of 3. Right?
Yeah.
So what this means is that n divided by 3 equals remainder of 2. Does that make sense?
Yes.
So n divided by 4 equals remainder of 2 as well. And then n divided by 5 is also a remainder of 2. Does this all look good to you here?
Yeah.
Okay. Let me ask you, if a number always leaves a remainder of 2, so let's think about it in an easier term. If a number leaves a remainder of 2 when divided by both 3 and 4, what number must that number be? The smallest possible number for that to be.
14.
14?
Oh wait, no. Smallest. Oh, 10.
So how did you get this
Wait, no.
10? Where did that come from? 10 is actually correct, but can you explain it to me?
So like, basically find the greatest common multiple. I mean, the least common multiple of 3 and 4. So that'd be 12. And then if there's a remainder of 2, you subtract 2. I think.
Oh, sorry, 10's actually wrong. Because 10 only leaves a remainder of 1 for 3, right?
Oh, so. Wait, isn't it 14 then?
Yeah, it would be 14. Yeah. Did I say
Oh.
14 was wrong earlier?
Yeah.
Sorry. I'm not I wasn't thinking straight. Okay, so it's actually 14 here because what you did is you said you go to 12, right? And then you need a remainder of 2, so you need to go 2 past that, right? If you divide 14 by 4, you get a remainder of 2. If you divide 14 by 3, you get a remainder of 2. The easiest way to think about this is if you have a consistent remainder across a bunch of different numbers, the easiest way to make sure you get that remainder from all those numbers is first find the least common multiple of the numbers that you're working with, in this case 3, 4, and 5, and then just add on the 2 at the very end. So you agree with me that the remainder of 2 is consistent between all 3 different things, right?
Yes.
So then what we see here is, yeah, that's what we're working with here. So then what we can do is we can take all of this and just figure that out, right? Multiply 3, 4, and 5 because 3, 4, 5, they share no common factors. Their least common multiple is going to be that 60, right? So then what's the number that works here for n?
62.
Yeah. So what's the next number that will work then? Is it going to be 62 times 2, which is 124?
Yeah, I think so.
That one actually ends up being not quite true.
Or would you have to add 2 again? Or
You would-
subtract? Or
Instead-
would, I don't know.
Think about it this way. So you are looking for a number that leaves a remainder of 2 when divided by 60. So why are you multiplying 62 by 2? Shouldn't you be adding on another 60?
So 62 plus 60, yeah.
Which would be?
122.
And then can't you do another 60 on top of that?
182.
So your starting numbers are 62, 122, and 182. And the reason why you don't multiply 62 by 2 is because that doesn't actually get you what you're looking for. You're looking for multiplying, just adding on another 60, right? Okay, well, is this it? Are these the only 3?
I think so.
What do you think this means?
We have to subtract 60 also.
What's the last one?
2. Yeah.
Because 2, 3, 4, 5 clearly works.
Yeah.
That's it. That's all you do here. So this idea here of saying, hey, these all leave remainders of 2, I think that part is pretty simple. I think that part's pretty clear to understand, right? And then from there, you can understand that, okay, well, what you can do here is say, all right, this n and n plus 1, we can find multiples of 2, multiples of 3, right? That just means that we always leave multiples of 2, remainders of 2 when we divide by 2, 3, 4, and 5. Well, if we leave remainders of 2, we just multiply those together, add 2. We're looking at 62. Well, we always want a remainder of 2 when divided by 60. So our numbers are 62, 122, 182. But then we also must consider the 2 at the very start. And that gives us these 4 different ones. 4 divided by 196 ends up giving us an answer of 1/49. That's the probability here. Any questions from anyone? Great, nice work here. This was not so bad either, as long as you think about it with the remainder idea. Now that can be a little bit tricky though, so no worries there. Right. Problem number 8, Isabella. Isabella?
So it says that A through H are 30, 60, 90 right triangles.
No. So the squares are A through H. The 30, 60, 90 triangles are the ones here.
Oh, okay. So the hypotenuse of a side of a square is the 60
The
degree
hypotenuse of a
angle.
side of a square? What? You
Yeah,
don't
for
call.
each triangle, its hypotenuse is the side of a square.
Oh, okay,
and
okay. Gotcha.
Yeah, and the side opposite is a 60 degree, and the side are different.
Okay. So
Square.
let's say, for
So-
example. Okay. What do you want to do here? Sorry.
I don't really know, but I was just so yeah. So the hypotenuse is that, and then so it means that is it the top angle sort of? That's the 60 degree, I think.
Which one's the 60 per one? Let's say 1, 2, and 3. Which one is the 60 degree?
I think it's 3, but I'm not sure.
3 is the 30 degree. It's clearly the smallest one, right?
Oh yeah, then it's 2.
So this was a 60 degree angle.
Yeah, so that's 60.
Mhm.
And then to the top one's 30, and then the other one's just a right angle.
Well, the top one up here is
So-
90 degrees. So this one is 30 degrees?
Yeah.
Okay.
I was thinking about it if it was like standing in like a normal sort
Oh,
of
okay.
thing,
You're
then the
saying
top
like
would
if
be
it was
30.
standing over here,
Yeah.
like from this angle.
So yeah.
Okay.
So they're asking which letter represents the largest square with area less than 1/2 of the square A.
Mhm.
So we have to find the area of A and then find an area that's and then find half of A.
Mhm.
So we
And
know
then
which
find when
one's
that
like,
breakpoint happens, right?
yeah.
So let's start by doing something that you may not have considered. What length do you want A to be? You can pick any number you want.
1.
Sure. If you pick 1 here, then what is half of the area of a square with a length with a side of 1?
Half.
Half. Well, what does the side need to be in that case then? Square root of 1/2, right?
Yeah.
Square root of 1/2 is a little bit annoying to work with, but I'll just give this to you. This ends up being the square root of 2 over 2. The idea is you just multiply by the square root of 2 over the square root of 2. It's a process called rationalizing the denominator. All right, so you're looking for a side that is smaller than square root of 2 over 2. Do you agree with me here?
Yes.
Okay, so what we can do here is we can think about it this way. Well, if this is 1, right, then what value is this?
Wait, which one?
Okay, so if this first side right here is 1, then what value is this side over here?
So this is 30, 60, 90. So 1, it'd be half. So just 1/2.
And then what would this other leg be then?
1/2 square root 3.
So root 3 over 2. Well, if this is
Yeah.
root 3 over 2, then that tells us what the side length of B is.
Oh, so that would be root 3 over 2 times root 3 over 2. So 3 over 4.
3 over 4 is the area of B. Well, then what is the side length of C? Well, can't we just do the same thing? Multiply by root 3 over 2? Because what we did here was we found, hey, if we just multiply it by the square root of 3 over 2, we get that's what my next side length is. Does that make sense?
Yeah.
So then this over here, this is going to be 3 over 4. Do you agree with me here?
Yes.
Well, 3 over 4, that gives me an area of 9 over 16, which is still bigger than 1/2, right? So we got to go to the next one.
Yeah, so that side's 9 over 16 then.
No, it's 3 over 4 times root 3 over 2.
Oh.
E would be 9 over 16.
Oh, that makes sense.
Well, I'll tell you this. This is the one. Because this ends up being 9 over 16 times 3 over 4 for the area, which is 27 over 64, and that's it. So your answer is D. Make sense?
Oh, yeah, that does.
Yeah, so all you have to do here is find the ratio of one side here to one side here, and then just go down the list basically. That's all we do. All right, moving on here. Problem 9 and problem 10. Problem 9. What is the greatest two-digit prime number such that the sum of its digits is also a prime number? Luke, I promise you this question's pretty easy. Any thoughts on how to do it?
Is it just going back from the top?
For the most part, but there is something that you can do a little bit to make it easier. Want to know?
I'm not sure.
Okay, so let me ask you, except for one prime, what is something that all the other primes share? Like, what is something in common with all the other prime numbers?
They're divisible by 1.
Well, yeah. Anything else? Every number is divisible by 1, though. Anything a little bit more specific that kind of at least cuts out like half of the numbers, maybe?
They won't end with 2.
Well, a little bit more specifically, they actually are all odd. Because if they're even, then they are divisible by 2. They cannot be divisible by 2 because they're prime. So in order to get an odd number for our sum, right? Because we're looking at an odd number, our two numbers, one must be even, one must be odd. If our two-digit prime number, one of them needs to be even, one needs to be odd, well, the even number needs to be in the tens place, not the ones place, right? Does that make sense so far?
Yeah.
So what we can do is we can look at our primes that are only in even tens. So that means like the 80s, the 60s, the 40s, you get my point, right? And we can also look at 11 because 11 is 1 plus 1 equals 2. That also works. If there's no other numbers other than 11, then we know that 11 must be it. But now let's look at the primes in our 80s. What prime numbers are there in the 80s? Do you know? Here you just have to have them memorized. That's really just it. So if you want to do computational mathematics, you're gonna need at least like the first 100 memorized. Like when I say first 100, I mean to 0 to 100, not like the actual first 100 individual prime numbers. Okay, what are they? Did you say?
83 and 89.
Okay, 83. What's the sum of those two digits?
11.
Yay, that works. But what about 89?
17.
That's it. That's bigger. 89 is it. See, like I said, I promise you, this question's really easy. You just have to have some primes memorized. All right, and lastly, but we did kind of like narrow things down a little bit by noticing we actually only need to look at numbers in the even tens, not odd tens at all. All right, problem number 10. If n is a positive integer less than 100, what is the sum of all possible values of n for which n squared plus 55 is a perfect square? Sarah, any thoughts?
I have no idea.
You have no idea. Okay. So for n squared plus 55 to be a perfect square, it needs to be equivalent to some other situation. Do you know what a plus b squared is?
Oh yeah. A plus b squared times a minus b squared, I think.
You're thinking of a squared minus b squared is equal to a plus b times a minus b. I think this is what you're thinking of.
Yeah. I don't know.
Okay. A plus b squared is a little bit different. I promise you this is really important. Between this and a minus b squared, these two you always want to have memorized. These are these two and a minus b, a squared minus b squared. So these three in total are all really, really, really important. All right.
Is it just a squared plus b? Wait, no.
That's a huge no-no.
A plus b squared.
A squared plus b squared. There's more. So the easiest way to think about this, the easiest way to disprove a squared plus b squared equals a plus b squared is 1 and 1. Is 1 squared plus 1 squared equal to 2 squared?
No.
No, right? This is equal to a squared plus 2ab plus b squared. This one down here is equal to a squared minus 2ab plus b squared. These two are formulas that you are going to want to memorize. If you want to prove them, the easiest way to do that is to FOIL. Foiling being multiply your first, multiply your outer, multiply your inner, multiply your last, add them all up. If you really want me to prove that, I could prove that afterwards here, but for now, let's just run with this, okay?
Okay.
All right, so what we know is that n squared plus 55 must be equal to some n plus m squared, right? Because this is a perfect square, which means that n and m both have to be perfect square, perfect whole integers. Do you agree with me?
Uh-huh.
More specifically, m also needs to be positive because it needs to be bigger, right?
Yeah.
Okay, so what we know is that, well, if this is the case, then this must be equal to n squared plus 2nm plus m squared, right?
Oh, wait, 1 second. Why does m have to be bigger than n?
Because you increased n squared.
Okay,
If you
got it.
increase the square of a number, the number itself has also increased.
Mhm.
So does that answer your question?
Yeah.
All right. So at this point, we are comparing n squared plus 55 and this number over here. So what's the first thing you can do?
Get rid of the n squares.
Not that. You can get, yeah, sorry. Did you say get rid of? I heard distribute for some reason.
I didn't say.
Okay. So yeah, get rid of n squared. So now you have 55 is equal to 2nm plus m squared. All right. Is everyone else following along so far? All right. Sounds good. So now what you want to do is you want to start plugging in numbers for m. Okay. What's the first number m can be?
It could be
1.
Oh, okay.
Right? Because if m is 0, then this doesn't work. 0 plus 0 is not equal to 55. So the first one, first number we can try to plug in is 1.
Mm-hmm.
Well, if we plug in 1, then what does this over here have to be? What does n have to be? 2n is equal to
55.
So n equals 27,
sorry,
right?
54. Yes.
Okay. So if n equals 27, m equals 1, this is one case that does work.
Mm-hmm.
All right. Well, what do we notice actually about m? M needs to be odd, right? Because if m is even, then this is even as well, right?
Uh-huh.
Which means that this would need to be even, but it's
Yeah.
odd. So
Yes.
m, we can only plug in odd numbers. What's the next number we can try?
3.
Okay. So if m equals 3, then that means that this over here is 9, which means that this over here becomes
46.
Is that equal to 2 times 3 times some integer?
No.
No, right? 46 is not divisible by 6, so 3 does not work. All right, next try. What's the next number? Let's try 5. Does 5 work?
Well, then m would be equal to, m squared would be equal to 25.
Mm-hmm.
So the other side would be 30.
Equals 2nm. 2 times 5 times n, that's 10 times n is equal to 30. What is n then?
3.
3. That does work. Next up, we can try 7, but you'll notice pretty quickly that 7 doesn't work. So your only options here are n equals 27 and n equals 3. Your total is 30.
Okay.
Any questions here from anyone?
Wait. Why can it only be n is equal to 27 and
Any bigger and n needs to be negative.
Okay, I got it.
Right, because any bigger, m squared starts making this over here negative, which means that this, you need a negative number here, and that just doesn't work.
Yeah, I get it.
Any questions from anyone else? So I promised that I would kind of explain the formula a little bit of a squared plus b squared. So let me just kind of go through that real quick, and then we'll call it a day. So a squared, a plus b squared is equal to a plus b times a plus b. So you can think of this as one term times something that needs to be distributed. So let's say that a plus b is equal to c first off. So this is A plus B times C. Well, we know what this is. The distributive property tells us this is AC plus BC. Well, now let's plug in this back in over here. We get A times A plus B times A plus B, which gives us A squared plus AB plus AB plus B squared, which then gives us A squared plus 2AB plus B squared. You can do a similar process for A plus B times A minus B or A minus B squared, and you will find both of those formulas as well. This formula, I promise you, is one of the most important ones. This one is probably the most important out of the three of them, but A squared minus B squared is the one that is most prominent on, it's the one that you'll see a lot of on competitions. But A plus B like this is the one that you'll see a lot in school. But yeah, so that's going to be it here. That's the end of the 2017 chapter exam. Next time we meet, that's going to be in the new year. We're going to be looking at the state exam. So yeah, with all that being said, if you guys have any questions, feel free to ask now. Otherwise, that's going to be it here because I don't want to start off a class like halfway in the middle of an exam, especially in the new semester, right?
Oh, okay.
Oh, did you have a question or?
No, I didn't. I'm
Okay.
just wondering why we're ending early.
Yeah, it's just because it's the end of the semester. I don't want to start off a whole new semester. If anyone's new to the class, I don't want to start off in the middle of an exam, right? That's just not right. So I want to start with a new exam at the start of the year. All right. Any questions here from anyone? If not, then have a good break. I'll see you guys in the new year. Have a happy new year.
Thank you.
holidays.
Happy New Year.
Bye.
for
See
sure.
you next year. Happy break.
See ya.
Bye.
Yeah, bye. See you too.